In this video, I'm going to describe and explain cognition model process methods. Process methods are really the core of cognition models, and they are what give cognition models their power, their ability to be able to model human behavior. And that's really what we're trying to do here with cognition models, is model human behavior. As you know from the user tutorials, we went over those videos went over the roles of the different models, the different types of models in Flames. And in those videos, we described the fact that cognition models are intended to represent the human behavior of an individual player. So those cognition models are making all the decisions for the player and controlling all the equipment that is attached to the player, to the units. And the core of that, what really does all the work, is the process methods. Cognition models are just a collection of a bunch of process methods. So these methods are fundamentally different in many ways from the methods of any other type of Flames class. In fact, the methods of any other class in any other system. They are very special type methods, and I'm going to tell you why they're so special here in the next few minutes. In an entity model, there's a bunch of methods defined by parent classes, and we looked at those in entity model development, the attribute methods, the IO methods, the user interface methods, etc. And then in equipment models, which we are going to which are covered in another video, equipment models have additional methods for each class. For example, sensor has detect, platform has move, additional methods that are called during scenario execution to perform the processing appropriate to each type of equipment model. Cognition models don't have any predefined set of methods. All the methods of cognition models are defined by the developer, by you or by whoever it is that did the development of the model. So you get to define any methods you want, because it's only you who know, or only the developer who knows, what particular type of behavior they want to implement with the cognition model. So this particular cognition model has just three methods, process methods. So, and then we use the word process method just as a way of distinguishing methods of cognition models from the other types of methods that might exist in Flames classes or in the classes of some other type of system. So the more full name would be a cognition model process method, or you might call it but it's not just a cognition model method, because there are other methods in the cognition model, like we have up here, clone and configure. These are methods of the cognition model, but these are the process methods. So they're very special methods. So let's just take a look at the structure of a process method. So I'm going to go here and take a look at the assess method. You'll notice, first of all, that the arguments to these particular process methods are all the same. And that's going to be true for every single process method that you write, every one that you see in Flames. All the process methods always have exactly the same input arguments. So what is it that makes process methods so special, and what is it that makes them so powerful? Well, what makes them so powerful and special is the way that they are called. So process methods are called in a very special way that is provided by Flames. And I'm going to contrast it with the way that normal functions are called. Normal function, you have a call in your code to that function. The execution of the code jumps to that function. The function completes its execution. It returns it back to the calling function, and execution continues. Process methods are never called directly. They're always called indirectly. And there's an example of an internal call down here in this code, this funit initiate command. So we pass in the name of a command, and we pass in a mal that's going to be passed through to this command, and then we pass in the unit, which is us, the unit for which we're initiating the command. There's an optional argument there. And so this is the way that we invoke process methods from within code. So they're invoked indirectly. And the term that we use is command. So we don't actually call the process method or execute the process method directly. What we do is we initiate a command. And that's the same terminology that you should be familiar with already from using the user tutorials. These are commands right here. So assess is a command. And as we mentioned, there's only one command for this particular process cognition model. But if we go look at some of the other cognition models, like just the shooter, which we're going to talk about later in these set of videos, this particular cognition model has quite a few commands. And if we go look at the commander, he's got several right here. The driver, he's got several. And if you look at more complicated cognition models, there'll be several more commands here, many more commands. So the terminology that we use is we initiate a command for a unit, which means we are initiating a command for the cognition models attached to the unit. And that command initiation ultimately results in the execution of one or more process methods. So again, we don't call process methods, we initiate commands that are associated with process methods. So here's a place where we are initiating command. We're initiating the engage command. And if we cannot see, I'm going to go back to our user interface for units. We don't see that command when we try to add it here because it's all we see is assess. But if I go back to the cognition model window and I click on EXM cognition and I look at the methods, you'll see that we do in fact have an engage command, but it's not showing up in our user interface, and you'll learn why that is in a little while. The other command that we support is configure on unit. So we have 3 commands, and each of those are associated with 3 process methods. So if we go back and look at our code and we go back and look at the declaration of our class, there's our 3 process methods right there, the same ones that were listed in the window that we just looked at. So again, we see how we initiate a command in the code through this call, but it turns out there are several more ways that cognition models can be, commands can be initiated. And again, every time a command is initiated, it usually results in the execution of a process method. So the other way that commands can be initiated is one that we've actually been using quite a bit, and that's right from the user interface. So I can initiate a command right here from the user interface, and as behind this command is actually a script statement, and it's this initiate statement right here. So this is initiating assess, and it's passing in the value of this variable called search range. So here's the second way that cognition models, process methods for cognition models can be initiated or can be executed, which is to say, here's the second way that commands can be initiated. They can be initiated from the user interface. So that right there is an extremely powerful feature of process methods and of cognition models. We actually have a system implemented in Flames that allows us to invoke the methods of classes through input data that's supplied through a user interface. And a real nice high-level interface, this command editor that we have. So that is something that can't be done with a normal, any type of normal class. There's no way to, unless it's an interpretive language and you're a programmer programming in that language. But we're not doing software development here. We have a graphical user interface on a finished program, but the cognition models give us the ability to initiate commands from the user interface. So that's something that makes them tremendously powerful. We get to tell our units, tell the human behavior of the unit, give those humans that are attached to the unit, we're able to give them commands from the graphical user interface. And that is the basis for scenario generation in Forge. We are building units, and the units, when we attach cognition models to them, have a set of commands, and those commands are available to us to be able to to initiate for the unit, so we can tell the unit what we want the unit to do during the course of the scenario. And as we've discussed in other videos, these commands are not defined by flames. And now you can see how they're defined. They're defined by the individual cognition models. And it's up to the cognition model developer to decide which commands the model is going to support. And those commands are all available, can all be made available to the end user in building the scenario. So we get to tell our unit to do anything that we want. We've illustrated this in another video, so I'm not going to do it here. But the other place where commands can be initiated, but I will run it here for just a second. So I'm going to pause it. And even though this doesn't do anything meaningful, I'm going to go to the unit commander. And I'm going to pick my test unit. Then you can see right here that I've got my commands that this particular unit supports, the same one that we saw in the units window. So the same ones that we see over here. But now the scenario is running. And we've actually already done this in another tutorial video, how you can control units during execution. So this is the third place that commands can be initiated. They can be initiated during scenario execution through the graphical user interface. So right here while Flames is executing, while Forge is executing the scenario, we can pull up any of the commands that are supported for interactive control for that unit and actually interactively give commands to the unit. So not only can you give commands to the unit prior to scenario execution, you can interactively give commands to that unit during scenario execution. That's a built-in feature of Flames, and it's built into the capabilities of process methods. And it's only because of these unique, very, very powerful capabilities of process methods that we have the ability to do that. And again, you as the cognition model developer, you get to decide which particular commands you want your cognition model to support, and which includes which commands you want to be able to give to your cognition model, give to the unit while the scenario is executing. So there's a third way that commands can be initiated. So again, very, very different from normal methods of any other type of class. So there's another place that commands can be initiated. I'm not going to do it here, but I think there are other videos where this was done. If I was running this scenario in Forge and I connected to the scenario from another computer or on the same computer with Flash, and I was monitoring that scenario, Flash can connect to any unit that's being executed and have a user interface just like this, the unit commander interface, and it can, from a location from a remote computer over the network, can give commands to units. So we're actually able to initiate commands from a separate process set up over the network through the same command interface, this unit commander interface. So there's a fourth way that cognition model process methods can be executed, how commands can be initiated. So it's like a remote procedure call. We initiate it in another process, and that ends up calling it for the unit. So you have tremendous amount of interactive control over units from client applications, and that's a built-in feature of Flash, and you can do that from custom client applications as well. You can initiate commands. There's a well-defined API for client applications to be able to initiate commands from clients. So those are four ways now that commands can be initiated, and a fifth way is actually sort of like the first way. We're initiating it internally, but we are not doing the initiation inside of our cognition model. We can have other models in Flames that are attached to the same unit or attached to different units that can make that call to initiate command and initiate commands for our unit. And Flames itself can initiate commands for our unit. So there are 6 or 7 different commands, we call them internally initiated commands, that are initiated by Flames when different things happen. Like when a unit dies, when it sustains damage, when it becomes active. And there are a number of other commands like that. Whenever it launches a munition, the munition terminates, we can evaluate the damage. So we get these events that take place during scenario execution that we can tap into just by implementing support for those particular commands. So that's really sort of a fifth way that cognition model process methods get executed. In other words, it's a fifth way that commands can get executed. So this way that we have, these multiple ways that we have of initiating commands for units, which means initiating commands for cognition models, this is one of the things that gives cognition models so much power. It's this incredible amount of power, and they are arguably the most significant, most important class in Flames, and they form the basis for scenario generation and interactive control of units. And again, it's all available to you. You get to write any commands that you want and implement any kind of behavior that you want. There's also something very significant about process methods, extremely significant, and it doesn't have to do with the way the commands are initiated, but it has to do with what happens when the commands are initiated, which also makes them very different from any other type of method of a typical class. So you see here, I'm initiating this command called engage, and that eventually ends up executing a cognition model process method that's in this file over here called engage. And so this is where that little statement comes out. Now executing this engage method, and it shows that it got the target ID. So I'm going to go back and look at the output here that came out when we were running. So here's where the assess method was initiated, and the method that we saw there, the output that we saw there came from this particular routine right here, FMH print, and then engage, as we just saw, made this little statement right here. So that message came out here, and then a little bit later it came out here. Well, what's significant is that it came out a little bit later. So when we initiated that command, assess did not get executed immediately. It got executed later. And this is perhaps of all the unique properties of cognition model process method, this is probably the most significant. Cognition model process methods do not get executed immediately. They get executed later in time. And that time is intended to represent the amount of time that it would take a human to actually perform that command. So that is really the key for allowing us to simulate human behavior. And that this particular technique, we invented it for Flames, and we find it very, very much superior to in most cases, not all cases, but in most cases to like expert system shells that have a hierarchy of commands that get traversed every time things get executed. We don't have that with cognition models. Cognition models always know their context, and their execution is always integrated within their context. We don't have to transverse a rule tree to figure out where we are and figure out what the next step is. These process methods, because they have this time delay associated with them, allow us to be able to establish threads or flows of human behavior that are taking a certain amount of time to execute. But no CPU time is being consumed during that time. We're not regularly polling these cognition models. They are not executed time step, which leads to a important part about these process methods. Because they are not executed immediately like a normal function call, all process method execution is event-based. And that's an aspect of the fact that they're time delayed. They are all event-based. Flames has an event calendar, and when a command is initiated for a process method, for a unit, like for example what we had in here in assess, no matter how it got initiated, if it got initiated from the user interface, from an executing scenario, from a client application, whatever way the cognition model command got initiated, this results in putting an event on the calendar for the process method as associated with this particular command. And there's places where you get to specify as a developer what point in the future you want this command to be executed. So what's the relative time from the time that it got initiated when it's going to get executed. So if it gets put directly on the event counter, so the process method and the cognition model itself is not consuming any CPU cycles while it's waiting for that event to occur. But having human behavior that is event-based instead of time step-based, again, and having all commands have the ability to be executed in the future to simulate the amount of time that it takes a human to perform the command, that is really key to being able to model human behavior. So that's what's unique about the process methods, the main things that are unique about them. And that is an overview of how process methods are executed. So that's all I wanted to talk about in this video, just to introduce you to process methods and how they're executed and how they're initiated, how they get called. So we'll get into what happens inside of process methods in a successive video. Thank you for listening to this video, and thank you for using Flames.